Good morning to everyone. This is Dr. YVNR Swami, Associate Professor in the Department of ECE. Today I am going to teach one topic in electromagnetic waves and transmission lines, that is electric field due to continuous charge distribution. Electric field due to continuous charge distribution. Here we will already discussed in the last classes, that is Coulomb's law, electric field intensity, and one problem on force and electric field intensity. So continuous to the previous topic is electric field due to continuous charge distribution. Okay, so first of all, electric field. Electric field, what is electric field? So if the charge is at rest position, it produces a field. That field is called electric field. Then coming to the electric field intensity. Electric field intensity can be defined as the force per unit charge. Unit charge. That is E equal to F by Q. And in the last class, we completed electric field intensity due to a point charge. Due to a point charge. So that electric field intensity is Q by 4 pi epsilon naught R square along AR direction. So in this formula, A suffix R is the unit vector whose magnitude is unity. It can be written as R by mod R. So then electric field intensity can be written as E equal to Q into R by 4 pi epsilon mod R whole cube, where R is the distance. So if we know the electric field intensity due to point charge, then we will see the electric field intensity due to a line charge, electric field intensity due to a surface charge, and electric field intensity due to a volume charge. So in today's class, we will discuss the electric field due to continuous charge distribution. Continuous charge distribution. Okay. So see here, electric field due to continuous charge distribution. So here, the force and electric field charges are occupying very small physical space. The charges are occupying very small physical space. Now, it is also possible to have continuous charge distribution along the line, on a surface, and in a volume. Okay, here, those things along the line, surface, and volumes can be represented as rho L, line charge density, rho S, surface charge density, and rho V, volume charge densities. So before discussing this line charge, surface charge, and volume charge densities, we have to define these line charge, surface charge, and volume charge. So first of all, a small charge Q occupies very small area or volume is called as a point charge. So a small charge Q occupying very small area or volume, that one is called as a point charge. A charge is at rest position that will produce as a field. That field is called as electric field or electrostatic field. Okay, so that field is produced by the charge. So now a small charge that occupying very small area or volume, that one is called as a point charge. In previous class, we already calculated the electric field intensity due to point charge. Okay, a small charge that occupies very small area or volume, that one is called as a point charge. Then second one, line charge. Line charge, okay, is charge uniformly distributed. A charge uniformly distributed along the line is called as a line charge. Okay, the charge is uniformly distributed along the line is called as a line charge. Line charge. In the same fashion, a charge uniformly distributed over a surface or sheet. A charge uniformly distributed over a surface or over a sheet is called as surface charge. Surface charge. In the same fashion, what is volume charge? Volume charge. So here, a charge is uniformly distributed throughout the volume. A charge uniformly distributed throughout the volume is called as volume charge. Volume charge. Okay. So now we'll discuss the point charge, line charge, surface charge, and volume charge. Okay. So these are the definitions: point charge, line charge, surface charge, and volume charge. Now we'll discuss these things in a brief. So here the charge element dq and the total charge q due to these charge distributions are obtained from the following figures. So now you can see here it is a point. So point charge, the charge is produced, it is a point charge, it is at rest position. It will produce in the field, that field is called as electric field. Now we will find the electric field intensity due to this point charge. So in previous class, we completed electric field intensity due to a point charge. What is the obtained formula for that one? E equal to Q by 4 pi epsilon naught R square along AR direction, where AR is a unit vector whose magnitude is unity. So this is the point charge. It plus Q, its electric field intensity. Electric field intensity due to this point charge is this one. E equal to Q by 4 pi epsilon naught R square along AR direction. Okay, so it is clear because it is already discussed in the previous class. Now we'll see the electric field intensity due to a line charge. Now you have to see the charge. These are the plus symbols are representing charges. These charges are uniformly distributed along the line. The charges are uniformly distributed along the line. That one is called as line charge. Okay, so its line charge density is represented with rho L. So for this line, I am taking a small differential length. This one is a small differential length. I am taking small differential length dl. That dl occupies charge will be represented with dq. Okay, so the line charge density rho L can be defined as the total charge per unit length. Line charge density is total charge per unit length. So then the dq is equal to rho L into dl. dq equal to rho L into dl. Then q equal to line integral of rho L dl. So this is the total charge. dq is the small charge. Okay, dl is the differential length. The dq is the small charge in the differential length. Then small charge dq equal to rho l into dl. Then total charge q equal to line integral of rho l dl. Rho l dl. Now electric field intensity, we know the formula is E equal to Q by 4 pi epsilon naught R square along AR. Now just replace Q with line integral of rho l dl. Then what happened? Electric field intensity E equal to line integral of rho l dl by 4 pi epsilon naught R square along AR. This is the electric field intensity due to a line charge. Line charge. Electric field intensity due to line charge. Okay. In the same way, surface charge. Surface charge. What is the surface charge? The charge is uniformly distributed over a sheet or surface is called as surface charge. Surface charge. Then what is the surface charge density? Surface charge density can be defined as the total charge per unit surface. Surface charge density is the total charge per unit surface. So now you can see in this figure, the charge plus symbols are representing the charge. The charge is uniformly distributed throughout the over a sheet. The charge is uniformly distributed over a sheet or surface is called as surface charge. Now I am taking a small differential surface area in a sheet. So that can be represented with ds. So this ds consisting of small charge dq. Okay, so then surface charge density is total charge per unit surface. Then small differential charge dq can be represented with dq equal to rho s into ds. Rho s into ds. So then q is equal to surface integral of rho s ds. Rho s ds. But we know the electric field intensity due to point charge is q by 4 pi epsilon naught r square along AR direction. Now just replace that q with this surface integral of rho s ds. Then obtain electric field intensity due to surface charge or sheet is E equal to surface integral of rho s ds by 4 pi epsilon naught r square along AR direction. AR direction. Where AR is a unit vector. Unit vector. That is the surface charge. Charge. Then go for the volume charge. Volume charge. This is the figure for volume charge. The charge is uniformly distributed throughout a volume. The charge is uniformly distributed throughout a volume is called as volume charge. Volume charge. Then we are taking a small differential volume, this one. Then what happened? Volume charge density, the total charge per unit volume. The total charge per unit volume. So we are taking a small differential volume dV, and this differential volume dV consisting of a differential charge dq. Then dq is equal to rho v dv. dq equal to rho v dv. Then q is equal to volume integral of rho v dv. Q equal to volume integral of dv. In the same fashion, you have to substitute or you have to replace Q with this volume integral of rho v dv in a electric field formula due to a point charge. Point charge. Then the obtained electric field equation due to volume charge is E equal to volume integral of rho v dv by 4 pi epsilon naught r square along AR direction. AR direction. So that is the electric field intensity due to a volume charge. Volume charge. Okay. So here in these formulas, in these formulas, rho L, rho S, rho V are the charge densities. Line charge, surface charge, volume charge densities. Okay. So this is the continuous charge distribution. Continuous charge distribution. That is electric field intensity due to a continuous charge distribution. Okay. So what is the point charge? The charge is a small charge, point charge, a small charge occupying very small area or volume is called as point charge. What is the electric field intensity due to point charge? E equal to Q by 4 pi epsilon naught R square along AR direction. In the same way, what is the line charge? The charge is uniformly distributed along the line is called as line charge. Then electric field intensity due to line charge is line integral of rho L dl by 4 pi epsilon naught R square along AR direction. Then surface charge. The charge is uniformly distributed over a sheet or surface is called as surface charge. The electric field intensity due to surface charge is E equal to surface integral of rho S ds by 4 pi epsilon naught R square along AR direction. Then volume charge. The charge is uniformly distributed throughout a volume is called as volume charge, and electric field intensity due to volume charge is E equal to volume integral of rho V dV by 4 pi epsilon naught R square along AR. Yeah. So this is the electric field intensity due to continuous charge distribution. Okay. I hope electric field intensity due to continuous charge distribution topic is clear to viewers. Okay. Thank you, one and all.